a discussion on Jacobians. Up till now, we have discussed about definition of Jacobian and composite function, that is chain rule on Jacobian, and functions are said to be functionally dependent by taking Jacobian is equal to 0 or this is not 0. If this is 0, then we are saying that this is functionally dependent, and if this is Jacobian is not equal to 0, this is functionally independent. After this, we will continue our article. In this continue sequel of this Jacobian, we will discuss Jacobian of next type functions. But before that, I will discuss some examples, and from these examples we will go towards our next type. Here we are considering one example: x plus y plus z is equal to u, y plus z equal to uv, and z equal to uvw. Then we have to find this value of Jacobian and show that Jacobian of xyz with respect to uvw is equal to u square. If we are observing this problem carefully, and if we have to find this Jacobian, first of all we should have either xyz as a function of uvw or uvw as a function of xyz. Then we can find any Jacobian easily. If suppose xyz as a function of uvw is given, then we can find Jacobian of xyz with respect to uvw, or uvw are given in terms of xyz, then we can find Jacobian of uvw with respect to xyz, and we are knowing this property j into j star is equal to 1. Using this property we will solve this example. But here if we are observing in this example, we will not write directly xyz as function of uvw, or uvw will not write in terms of xyz. If we are observing in this problem, we will not separate xyz in terms of uvw, or uvw will not separate in terms of xyz. Again, here problem is there to solve such a type of problems. Now again we will go towards next example. Here u cube plus v cube plus w cube is equal to x plus y plus z, u square plus v square plus w square equal to x cube plus y cube plus z cube, and u plus v plus w is equal to x square plus y square plus z square, and show that this is Jacobian. Again, here to find out this value, we will not separate uvw in terms of xyz or xyz in terms of uvw. If we will separate, then we will find value of Jacobian. Here we will not write xyz in terms of uvw in above these examples, or we will not write uvw in terms of xyz. Then what we have to do? How we will solve this type of problems? Now to solve this type of problems, we have to develop new technique to solve Jacobian, to find such a type of Jacobians. This new technique is developed by implementing implicit function. We are implementing implicit function. By using implicit function, we will find this type of Jacobian. Now what we have to do for this? Suppose we have three equations in first example. In second example also we are getting three equations. This is first one, this is second one, and third one. What we have to do? By using these three equations, I will consider, suppose I will add new function, and we will say that this is implicit function, new implicit function, and I will combine first equation by that function. Second equation again I will combine by that function. The third equation I will combine by that function. Means if we have three equations, we can have three new implicit functions, and if we have two functions, then we have two implicit functions. Now we will go towards this idea. Here Suppose we have uv and xy terms, or xy in terms of uv terms. I will combine this equation by taking which is equal to 0. In last case also we have 3 equations and we have to combine these 3 equations by 3 functions, and second equation will combine by this by taking is equal to 0. Then if we have to find this Jacobian of xy with respect to uv is equal to, directly formula I will write here, minus 1 square this Jacobian divided by this Jacobian. How to write now this Jacobian? Here Jacobian of xy with respect to uv. Now here this xy, first of all we will write denominator. This is the Jacobian of f1 f2 with respect to xy. Then numerator we will write Jacobian of f1 f2 with respect to uv. Here denominator is there, therefore I will take this with respect to uv. Here xy numerator, therefore I will take here with respect to xy. This is your formula. A similar way we will write this formula as here Jacobian of uv with respect to xy. We will write first of all denominator Jacobian of f1 f2 with respect to uv, then numerator Jacobian of f1 f2 with respect to xy. This is very easy, and here minus 1 raised to 2. Suppose we have 3 equations, then we have to take 3 functions. Here f1 function of xyz vw is equal to 0, f2 xyz vw equal to 0, and f3 xyz vw equal to 0. Then we have to find this Jacobian of xyz with respect to vw is equal to minus 1 raised to 3. Here Jacobian of, first of all we will write in denominator Jacobian of f1 f2 f3 with respect to xyz. In numerator Jacobian of f1 f2 f3 with respect to vw, and here we have to write minus 1 raised to 3. Again here if we have to find this Jacobian of uvw with respect to xyz is minus 1 raised to 3. Here numerator uvw, then I will write in this denominator Jacobian of f1 f2 f3 with respect to uvw, and in numerator here xyz is there, in numerator I will write here Jacobian of f1 f2 f3 with respect to xyz. And this is for 3 functions. 4 functions, 5 functions are there, but we are not interested about these 4 and 5 functions. First f1 and f2 2 functions, and f1 f2 f3 3 functions. Then we have to solve Jacobian of this. Here we are solving Jacobians by taking implicit function f1 f2 f3. We are inserting implicit functions, and by using these implicit functions we will find values of Jacobian. Means here to find out this type of Jacobian we have to solve numerator as well as denominator. Numerator is 1 Jacobian, denominator is 1 Jacobian, and solving this will get here value of this our required Jacobian. To write here formula for 2 by 2 we have to write minus 1 raised to power 2. For 3 by 2 we have to write here minus 1 raised to 3. If n functions are there, then we are developing same theory by taking minus 1 raised to power n. Okay, this is our about implicit function, and when we are applying implicit function we will not separate our given equations in terms of either xyz in terms of uvw or uvw in terms of xyz. Then we can insert and consider implicit function, and by using this implicit function we will solve Jacobian. We will find value of Jacobian. Now again remember this formula, and to write formula first of all by given Jacobian, first of all write down denominator and then write down numerator. Using this easily we can write our formula. We'll go towards example. If u cube plus v cube is equal to x plus y, u square plus v square equal to x cube plus y cube, then show that Jacobian of uv with respect to xy is equal to 1 by 2 y square minus x square divided by uv into u minus v. Again, if we are observing this problem straightforward, we will not write uv as a function of xy. We will not write u is equal to and v is equal to. Therefore, we have to we have to choose implicit function and we'll write here implicit function. Again, how to write implicit function? From first equation, we should take this right hand side to left hand side and consider is equal to 0, and suppose this is our first function. Here also take this right hand side to left hand side and consider is equal to 0, and this is your second implicit function. Or you can write in this way also. You should take this left hand side term to right hand side and consider 0. Here also left hand side to right hand side, doesn't matter. Means only what we have to do, we have to take all terms to one side and write down equal to 0. This is your implicit function. Here I will take first f1 as u cube plus v cube. I am taking this right hand side to left hand side, and this is minus x minus y. This is equal to 0. Therefore this is our function f1. f2 also similar way we can write u square plus v square minus x cube y. This is very easy to write implicit function. By using given equations, we have to write these equations equal to 0 by taking terms to left hand side or right hand side, and this is our corresponding implicit functions. f1 and f2, we have two implicit functions, and by using these two implicit functions, we have to write down formula for Jacobian of uv with respect to x, and we are knowing this formula. How to write this Jacobian of uv with respect to xy? This is minus 1 raised to 2. Then we are writing, first of all write down numerator and denominator, and then we write first here denominator. In this denominator, Jacobian of f1 f2 with respect to uv, and numerator term Jacobian of f1 f2 with respect to xy. This is equal to minus 1 square is plus 1. This is n divided by d. N divided by d means numerator divided by denominator. We will find separately numerator and denominator. Numerator. This is Jacobian of f1 f2 with respect to xy. What is definition? This definition is we are finding partial derivative of f1 with respect to xy and partial derivative of f2 with respect to xy. This is our definition of Jacobian, and easily we will get partial derivative of f1 with respect to x. This is minus 1. Partial derivative of f1, this is again minus 1. Partial derivative of f2 with respect to xy. This is with respect to x is minus 3x square, and here with respect to y is minus 3y square. We'll solve this Jacobian. Again, to solve this Jacobian, you can use property also. You can take from first row minus 6 is common, from second row minus 3 is common. Using this we can solve, or otherwise we will get directly. This is simple one, that's why you will get directly 3 into y square minus x square. This is your numerator. Then denominator. Denominator is equal to Jacobian of this Jacobian of f1 f2 with respect to uv. Again, formula is we have to write here first row derivative of f1, partial derivative of f1 with respect to uv, and second f2 with respect to uv. Again, we have to write here derivatives of f1 with respect to u and v. U is here 3 u square and v is here 3 v square, and derivative of f2 with respect to uv. This is 2u and this is v. I mistake here, u is there, but this is v square. This is 2. This is 2. Which is equal to, again you can take from numerator, from first row 3 is common, from second row 2 is common, then from first column u is common, from second column v is common. You can use this property of determinant, or directly you can solve this and we will get this result. This is your numerator and denominator. Putting this value in numerator and denominator, we will get our required result. You should solve this problem, and you should solve this problem, and in this we are getting 3 equations, x, y, z, and u, v, w. Will not separate this. Therefore we have to insert implicit function, and using that we'll solve this problem. Again, when we are taking implicit function, the problem becomes somewhat easy. Means orally we can find here partial derivatives. Here we are taking f1 xyz minus u equal to 0, f2 xyz minus uv equal to 0, and this f3 z minus uv. What will be our formula to write this Jacobian? Jacobian of xyz divided by Jacobian of uvw is equal to minus 1 cube. Now denominator will write here Jacobian of f1 f2 with respect to xyz. Numerator will write Jacobian of f1 f2 with respect to uvw. This is minus numerator divided by denominator. Now we will find numerator and denominator separate. Yeah, this is numerator. Jacobian of f1 f2 f3 with respect to uvw. We will write here our determinant. We will find here derivative of f1 with respect to uvw. Here derivative of f1 with respect to uvw is very easy. This is minus 1 0 0. Derivative of f2 with respect to uvw. With respect to u, we will get minus u. With respect to v, we will get minus u. And with respect to w, we will get 0. Here, derivative of f3 with respect to uvw. With respect to u is minus vw. With respect to v is minus uw. And with respect to w is minus u. Now this is we are getting triangular matrix. And we are knowing property of triangular matrix. Determinant is nothing but just multiplication of diagonal elements. We are getting diagonal elements, and this is your numerator n. Now we will find denominator. Is a Jacobian of f1 f2 with respect to xyz. Again we will find here easily these values, and we are getting only identity matrix, and determinant of identity matrix is always 1. This is 1. Therefore numerator divided by denominator is our Jacobian. This is equal to, if we are putting all these values, numerator divided by denominator, then we will get this is equal to our required result u square. We will solve this problem also. We should go through this problem. I will give hint to solve this problem. We will take 3 functions. Now as per our definition of Jacobian or inserting implicit function, this is our numerator divided by denominator. This is our numerator. We will find here partial derivative of numerator with respect to xyz. This is minus 1 minus 1 minus 1. With respect to again f2 with respect to xyz is 3x square minus 3y square minus 3z square, and f3 with respect to xyz is minus 2x square minus 2y square minus 2z square. Now we have to find here, this is show that in factors form is given, therefore we have to apply our rules for this determinant. If you are solving directly determinant, then it becomes somewhat difficult to find the factors. Now here we have to apply our rules. So from first row minus term is common, from second row minus 3 is common, from third row minus 2 is common. Therefore I will take this. Now try to make this term and this term 0, because this is easy to convert into 0 by using column transformation. Now I will use column transformation. C2 minus this C1 and C3 minus C1, and we will check what will happen. We will use this C2 minus C1 and C2 minus C1 and C2 minus C3 minus C1. We need to write C2 minus C1 and C3 minus C1. Then we will get this result. Again here, if we are observing this from second column and third column, this is y square minus x square. This is z square minus x square. We can write here these factors as y minus x, y plus x. Here z minus x, z plus x. Therefore we will get here, I will write here factors. And from this column, here y minus x and here is y minus x. This term is common. From this column, z minus x is common. I take this terms common. Now I am taking these 2 terms common and remaining term is here. Now we will find here determinant easily because these 2 terms are already 0, and we are taking cross multiplication, we get this value of determinant. And this value of determinant is this. Now we will find denominator. Now we have to take partial derivative of f1 with respect to uvw F2 with respect to UW and F3 with respect to UW. We will get here 3 square, 3 square. Now that means here from first row 3 is common, we will take 3 outside. Second row 2 is common, we will take outside. We have to use properties of determinant and easily we will solve this determinant. Then here is 1 1. Therefore we will subtract this column C2 minus C1 and C3 minus C1. Then these two terms becomes easily 0. Here we have to write C2 minus C1 and C3 minus C1. And again here V square minus U square will factor it and then we will take common. Here I am taking factors for this. Now here V minus U from second column is common. From this third column W minus U is common, we will take outside. Here. Now we will solve this. Directly we will solve this determinant and then we will get value of this determinant is equal to 6 V minus U, W minus U, V minus U. This is our D, and by putting these values in our formula, we will get our equation. Now some exercises are also there. We should go through these exercises and try to solve all these exercises. Okay. Thank you. In again coming article, we will discuss next part of Jacobian. Okay. Thank you.